Thank everybody for coming. My name's David Harrington. I'm the newest addition to the QuickDraw 3D team. I'm the new evangelist working in conjunction with Sean Hopwood, who's the senior product manager for QuickDraw 3D. To start off this morning, we'd like to give you a quick overview of what we've done since the last Worldwide Developers Conference. In November of this past year, we released QuickDraw 3D 1.5. And with the release of Comdex, we actually won Best of Show. We've really added a lot of the new additional functionality with QuickDraw 3D 1.5, including plug-in rendering support, plug-in group support, and it's also the first version which is truly a cross-platform implementation, shipping both the Mac version and the Windows version in a simultaneous release with a common code base. So if you implemented or have implemented a Macintosh application, it should be very easy to implement on the Windows PC side. We also use native Windows NT services, and we'll actually talk about those services a little bit later on in the presentation. As application vendors, there's really several different ways that we can implement QuickDraw 3D inside of your application. If you have an existing 2D application, such as Adobe Photoshop per se, you can implement just the viewer. And the viewer will allow you to import and manipulate 3D MF objects inside of your application. So it's a great way to go and add a new data type to your existing product. For the game vendors out there who already have existing graphics libraries, we can also implement at the Rave level. Basically, Rave is our hardware abstraction layer, allowing your games to take benefit of Apple's or third parties' hardware acceleration. Or if you're looking to get geometries, you're looking to get plug-in rendering support, you're looking to get 3D MF file format support, you can implement our entire core library. So there's really a wide variety of levels that you can adopt Apple's QuickDraw 3D technology. And throughout the day, we'll be showing you demonstrations of each one of these and the performance that it can provide. One of the newest additions to QuickDraw 3D 1.5 is plug-in rendering support. We're actually going to have several demonstrations a little later on in the day showing you products both by Lightworks as well as ThinkFish Technologies, really extending the capabilities and rendering support that QuickDraw 3D provides. Out of the box, Apple provides both wireframe rendering and interactive a renderer, where Lightworks and ThinkFish are providing really a lot of additional options, including ray tracing, high-quality rendering, cartoon rendering, blueprint rendering. And once again, we'll see several examples and demonstrations throughout the presentation. We also see a wide variety of third-party accelerator vendors stepping on board to really back QuickDraw 3D. At the top, we have a wide variety of chip makers, including 3D Labs, 3DFX, SMOS, ATI, as well as several finished product boards. Some of those boards include boards from ATI. 3DFX is looking at working with third parties to release new products, as well as Radius at the high end of the product line with their Thunder 3D card. With that, I'd like to invite both Debbie and Scott from 3DFX to come up and give a quick demonstration about the power and flexibility which their chipset provides. So, Debbie and Scott from 3DFX.
Thank you very much. I'm Debbie Chen with Developer Relations at 3DFX Interactive, and this is Scott Alden, who is with our developer support team. We'd like to thank Apple for letting us spend a few minutes with you today. We are a graphics semiconductor company that was founded on the premise that software, not hardware, would drive our growth. Entertainment software, specifically game software, is arguably among the most graphics intensive of all software applications. It traditionally had to be written and licensed to closed hardware systems, such as a coin-op box that you see in the arcades or a game console. By providing a scalable graphics architecture to link the different entertainment markets, such as the arcade and the home computer markets, we enable our developers to debut games in one market and, in a straightforward manner, redeploy or re-express that content to another platform, because they have a common hardware platform that is PCI bus based and a common graphics target to write to. Has this been done before, moving from, say, the arcade market to the home computer? Certainly, and we've seen it over and over again. And that's what's exciting to gamers, is that you can go to the arcade and play a new game and then bring it into the home later for a different kind of experience typically. But what's different today is that these developers can now put more energy and creativity into tailoring the gameplay and the levels for the home, say, rather than spending their time on wrestling with hardware and API porting or moving their rendering engine from one target hardware to the other. And this results in a number of benefits, including reduced cost to the developer, preserving the quality of the title so that it looks the same or similar in the home as it does in the arcade, and we believe results in a greater volume of content now that it can flow more freely between the different segments of the market, which in the end is what the gamer wants. Developers, in fact, helped us design our first product, which is Voodoo Graphics, as well as the new Voodoo Rush graphics chipset. They told us they wanted powerful graphics with no compromise in performance. They wanted to be able to use all of the features that you would expect in a full high-performance 3D system, including features such as MIP mapping, a Z-buffer, alpha blending, bilinear, or more advanced filtering, and all of this in one system that would run at a sustained 30 frames a second, which is really what we look for an interactive feel in a game or in other types of software. And all of this, of course, at prices that are affordable to consumers. Have we succeeded? We'll let others speak for us. Computer Gaming World recently awarded us their 1997 Product of the Year. If you surf to Next Generation's game site, one of the most heavily trafficked game sites, which a lot of you probably know, you'll see that their recent poll showed that more readers own a 3DFX based board than and all others combined. So there's a lot of data out there. But perhaps what's most important to you as software developers is, of course, access to robust, stable APIs and drivers, nearest and dearest to your hearts. We absolutely support QuickDraw 3D. Our drivers today are in early beta, and you can contact us to get access to those. And we do support the other industry APIs listed here. For your information, for those of you for whom this is your first introduction to 3DFX, Glide happens to be our own low-level rasterization library. It's not an API by any means, but is used often by CoinOp developers and other game developers who already have written their own rendering engines. This breadth of drivers and APIs is what enables developers in these diverse markets, from scientific visualization to the arcade to the home computer game developers, to access the power of the hardware and really enhance the experience that their customers and your users get. Just a couple quick points and then we'll kind of get to the beef, which is the demos. We are working together with Apple to bring you this technology. Apple and their licensees rely heavily on your feedback, and we ask you to, based on what you see today, to contact them and be vocal about how you think this would enhance your business and enhance your users' experience. We are partnering actively with Mac game developers and publishers such as Interplay and GT Interactive to bring more high-quality games to the Mac. As an aside, we also would invite everyone here to stop into the games area in the Cyber Cafe, where we have GL Quake running on a 3DFX board in a power computing system. We are also actively looking to work with developers who are doing 3D content of all types, 3D applications of all types, such as internet, authoring tools and web browsers, anything that you can think of. If it's 3D and pushes the limits of what 3D and QuickDraw can do, we are looking to work with you. So please contact us. Any of the methods you see here, surf to our website, and there's a lot more information. Lists of current games are available there. And we know that the best way to evaluate what you see here today is to really experience the technology. So I'm happy to introduce Scott, who will show you what we call the magic of Voodoo.
Okay, what I've got here is one of our internal technology demos called the Valley of Ra. The scene consists of approximately 5,500 polygons, texture mapped, and right now I've got none of the special features turned on. So as I talk to it, I'm going to just turn them on. First is the bilinear filtering. and MIP mapping. And you'll notice that the aliasing on the Anubis character on the left has cleaned up dramatically. This is kind of just like a little fighting game to show some things that could be done with the hardware. And notice that the frame rate's very high. Quick response. There's another little feature, the reflections in the ground, which is kind of a nice little addition. Okay. This was written using our internal game developers toolbox called ATB, which stands for Arcade Toolbox, and you can get it from our developers Mac release CD. For my second demo, oh, someone turned off my virtual memory.
The other thing I might mention, I don't know if you did, is that we are live here.
GLQuake's a beast.
The other thing that I wanted to mention too about Valley of Ra, which is kind of a hallmark demo for us. When we debuted it last year, we've been showing it for the better part of a year. So for us, it's a bit dated, but it really does show you that a scene with a depth complexity of 3 or more, with high polygon counts of approaching 5,500 polygons in that scene, really does run at 30 plus frames a second. Each of those fighting characters was about 2,500 polygons each, and certainly you can dummy down the count and so on, but what we like to see and what we think enhances the realism of the experience is high polygon count models and very complex scenes. And as you notice, with all the different special effects turned on, we still have the playability of a 30 frame per second experience.
Okay, that's just to whet your appetite. GLQuake was a version done by John Carmack that's implemented using OpenGL. And 3DFX has a mini GL driver on the PC, which I was recently ported to the Mac, and got the source from Lion Entertainment for GLQuake with all the sprockets, sound sprockets and input sprockets turned on. Ported pretty well. I just wanted to show you some of the special effects kind of quickly that you can use with the OpenGL version. First of all, reflections are coming in. Oops. What? Just in case you're ever in a death match and someone jumped in the water to get away from you. You can kind of see them now. So, kind of adds a new depth to the game. There, the water is totally transparent. And that's my demo. Thanks.
Thank you.
Great, thank you very much. As we've heard throughout the conference, we're also adding more and more 3D acceleration directly to the logic board. The current Gazelle product line, including the 5500 and 6500, also have the ATI Rage 2 chipset built directly on the logic board. So with hardware being added, especially as we move forward, also moving into the Philips Trimedia chipset, really this gives us the power we need to really show the capabilities of our great game developers. With the new port for QuickDraw 3D to Windows, we also offer some new capabilities of being able to leverage the direct 3D hardware accelerator cards that are already on the market. What we've done is we've created the D3D to Rave engine that actually allows us to layer Rave on top of D3D. So it's a real good developer proposition that allows our developers to get access to the hardware on the Windows side as well. But we noticed that when we layer Rave on top of QuickDraw 3D, we get about the same performance as a native D3D game. But if you write a native Rave driver, you get about a 2x performance. So this is really a big incentive to our hardware vendors on the Windows side to do a native Rave implementation, but for those of you who currently do not have one, we can still leverage all of the existing Windows hardware accelerator cards on the market. Also with our Windows port, we use native file I/O, we use native draw content, so a Windows release really uses the power of what Windows is capable of doing as well as leveraging the capabilities of the hardware. For a quick demo, what we'll do is, if we can light up machine number 4, ATI has already written a native Rave driver for their Windows hardware accelerator cards. So here's a brief example of native Rave support on Windows. We can also launch existing applications like TextDrive, which has been very popular on the Macintosh, bring it up on Windows, go turn on auto rotate. So we notice the power and the performance of 3D acceleration hardware even inside of a Windows environment. So it's really a great cross-platform API for your 3D development. Also throughout the conference, we've already seen that we've ported QuickDraw 3D to OpenStep. We are going to guarantee compatibility with QuickDraw 3D running in the Blue Box environment under Rhapsody, as well as a native port to the Yellow Box. We've also seen the implementation on stage in Avi's presentation that you can also access QuickDraw 3D through Java. So there's actually an in-depth session on Friday where they actually get into exactly how you would implement QuickDraw 3D through Java, but we're going to be a great partner on the Rhapsody platform as well. Sort of the roadmap for QuickDraw 3D, we did ship QuickDraw 3D 151 that added some bug fixes, some additional native support. Late this year, we're looking at implementing QuickDraw 3D 1.6. It's mainly going to be a performance release that also offers VRML 2.0 rendering compliance. So we're looking at being a better VRML citizen. We're also going to implement our first draft of the shader interface. The beginning of next year, we're then looking at implementing QuickDraw 3D 2.0, and that's where we'll actually implement the shader interface, as well as roll out a next-generation hardware abstraction layer that will give you more details as we get a little bit closer to doing that. As we saw in several presentations, and we'll also show you again in a demo later in today's presentation, we also have WorldPlug, which is a Netscape and Internet Explorer plugin that allows us to display 3DMF models directly inside of our web pages. So I don't know how many people just came from Peter Hotty's demonstration, but really being able to deploy QTML all over the internet to make it seamless and make it as easy as possible. Apple will actually roll out that plugin later in the year, and once again we'll hear some more information on that later on. We're also now offering 3DMF file references, basically having one file be able to point out to multiple files, decreases the size of the download, really gives us a lot of additional speed, as well as making significantly smaller file sizes. We're also looking at implementing a walkthrough mode in the QuickDraw 3D viewer, actually allowing users to navigate space instead of really just being able to manipulate an object. And enable plug-in rendering, including cartoon, interactive rendering, and BSP rendering. Up to this point, Apple has not played a very big part in VRML. We've really been busy implementing the features that we have in QuickDraw 3D 151. We're really looking at changing that, and there's several ways that we are doing that. We actually now have a seat on the VRML board, so we are a voting member. We're creating alliances with a lot of third-party VRML vendors, and we're really looking at adding and fixing technologies inside of the current QuickDraw 3D implementation to add better VRML support. There is a wide variety of partners that we're working with. Apple, IBM, and Paragraph are working on the VRML 2.0 binary collaboration, looking at making the files much smaller, faster delivery, and offering geometry compression. We're also working with Silicon Graphics to license their VRML 2.0 compliance browser called Cosmo Player. And we're also looking to partner with other third-party vendors. So if you are a VRML vendor, we'd love to talk with you. Here's some of the other VRML vendors out on the internet or in the market who are creating Macintosh products. And we'd also urge you to go to their web pages, see exactly what they're doing. InterVista has a C-based VRML browser called WorldViewer, and here's their URL. DimensionX has a Java-based VRML browser called Liquid Reality, and of course Paragraph is out there. So we urge you to go to their web pages and look for their Macintosh clients becoming available very shortly. With that, I'd now like to call up Philip Schneider, and he's going to get into a little bit more detail on exactly implementation of 3D plugins, as well as some of the new features of QuickDraw 3D 1.5 and 1.5.1. So, Philip?
Good morning. Can everyone hear me out there? Yes. I can't see you, so if you raise your hand to have me speak up, I can't see that. Okay, I'd like to talk to you today a bit about some of the new features in QuickDraw 3D 1.5 and 1.5.1, and a few things that aren't necessarily new features, but are important enough we'd like to say a few words about them. We assume that most of you are somewhat familiar with QuickDraw 3D, maybe programmed in it, looked at the API. For those of you who are new to it, we've got a total of a slide for you, so don't blink. We'd like to point you at the develop articles that are available at the URL that you see on your screen there. They provide a lot of useful information that, on top of the documentation that you can find. And I'll be referring to a few of those as I go through my discussion. And here's the beginner slide. The basic understanding that you need to start off with QuickDraw 3D is to understand the concept of our view, which is an opaque object that brings together the cameras, the lights, the draw context, which is what you render to, and the renderer. To the view, you submit geometries, transforms, and styles to get your image drawn. And that's about all I'll say, except to point you at a very useful article, Develop Issue 22, QuickDraw 3D, New Dimension for Macintosh Graphics, gives you a basic overview of our architecture and will help get you started. One thing that I'd like to point out is that on our SDK, we always provide two separate shared libraries. One we call the debugging version, and the other, for lack of a more interesting name, a retail version. The debugging version offers you several things, one of the most important of which is we attempt to validate the incoming parameters for correctness, looking for the aspect ratio on the camera being correct or that sort of thing, and to provide you as a developer with a mechanism for catching those inadvertent programming errors early. In addition to that, we have a tool called 3Debug, which is again available on the SDK, that allows you to look at your memory usage in your application. This requires you to be using the debugging version of the library. Okay, let's launch into the new features section here. One of our new features in 1.5 is the feature of working on Windows, that is Windows 95 and NT. Our porting philosophy is to allow the developer to write an application on the platform using the standard tools and conventions that are available on that platform and the built-in data types in their libraries. To this end, our Windows port uses the native file I/O, uses native draw context, and I'll be getting to that in just a moment. We have a Windows native viewer that is exactly analogous to our Macintosh viewer that's provided. And probably more important to a lot of folks is we will be able to, as David mentioned earlier, access hardware acceleration through this D3D Rave engine. As I said, our system is intentionally cross-platform from the get-go, and sort of evidence of our success at that is the fact that we need only 3 Windows-specific data types or objects to get full functionality on Windows. The other 99.9% of our API in our system is completely platform independent. These new Windows-specific objects are 2 Windows-specific draw contexts and a Windows-specific storage object. The first kind of Windows NT 95 draw context is what we call a Win32 DC draw context. And the DC is there because it is, in fact, compatible with the existing code base for Windows, where the access to the Windows system is through the DC. And just a note for the Windows programmers, you have to use the CS own DC window class style, whatever that means. Normally, I shy from having anything that looks like code on a presentation like this, but I've included the data structure for our draw context on Windows, and you can see that there is the one field, the HDC, that gives you the connection to the Windows system. The other TQ3 draw context data is the common data that controls the draw context for all platforms. So it's very easy to port by using the existing, if you're going from a Mac, for example, to use the existing code that sets up your draw context data, and then just throw in the HDC for the connection to the Windows system. Our second type of draw context on Windows is what we call a DD surface draw context. This allows you to take advantage of the 2D hardware acceleration for blitting and clearing and that sort of thing. But Windows programmers out there know that this is a bit more complex. This can be seen in our own data structure, where we've encapsulated the extra setup parameters and values in this TQ3 DD surface descriptor data structure. My apologies for the long names, but it's kind of a tradition with us. As I said, we have a Windows native viewer available for Windows 95 and NT, analogous to what we have on the Macintosh. And I think, can we show something on that, Nick?
Yeah, on this machine, which is a Windows 95 machine, I've got the viewer up here. I'm going to drag a piece of 3D model from Plastic Thought, a Canadian developer we've been working with. You'll see some of the new features of the viewer. You'll see that the interaction's been changed so that the virtual sphere has been implemented properly. So you'll see the object's only going to move when we're dragging across the inside of the virtual sphere. We found this has actually made it an awful lot easier than the 1.0 viewer to manipulate things. Other new features that we've got in the viewer, we have a pop-up menu so that you can get a left view or a top view or whatever, which is pretty cool. We also have a home button, so if you kind of get lost, we can reset the view. The viewer is exactly the same on Windows as it is on Macintosh, and we're planning on doing a similar implementation of the viewer on Rhapsody. So basically, what you see on the Mac is what you get. This is a sample app that we've got, and I'm going to be using this for a demo later on. We'll be putting the source code for this on the SDK that should ship at the end of this month.
Another new feature for our version 1.5 is an extension to our own extensibility mechanism. For those of you who aren't familiar with this, we have a plug-in architecture that allows the application to extend the functionality of QuickDraw 3D without having us to put it into the core API. This can allow you to customize, add more features, and we'll see how that works in just a moment. In 1.5, we have 3 types of objects that are extensible. That is, elements and attributes, groups, and renderers. Renderers being probably a very significant one for our functionality. And as David referred to earlier, support for plugin shaders will be forthcoming, which I suppose means real soon now. There's a bit of commonality to all the plugins, irrespective of what type of an extension class you're extending. That is loading and initialization. On Mac, we use the CFM. On Windows, DLL loader. The application, the extension itself, provides a registration function that allows us, that is QuickDraw 3D, to load these libraries. The second thing they have in common is what we call a meta handler, which is essentially a method dispatcher specific for the plugin class. And of course, termination functions allow you to disconnect the extension, though these are automatically disconnected and unloaded when you call the exit function in QuickDraw 3D. Like I said, plug-in renderers are one of our more significant advances to the API. They're similar, as I said, to the other extensibility. The one difference is that because of the inherent functionality required for a renderer, there are sort of two levels of meta handlers, sort of a meta handler and the second level meta handlers, which allow you to plug in your functions for handling which geometric primitives are drawn, transforms, styles, that sort of thing. Now, renderers are somewhat complex by their nature, so we provided a couple sample renderers on the SDK and documentation which you can find on the SDK as well. We encourage those of you who are intending to either use or write plug-in renderers to contact us early on in your development, because we can provide a lot of help. And the motivation for this is obviously that we can leverage off of existing functionality or new functionality that third parties want to provide to give new rendering capabilities to our system. Now, how does a plug-in renderer fit into the system? Well, the two big blocks of interest are QuickDraw 3D itself and QuickDraw 3D Rave. QuickDraw 3D handles the geometries, the transforms groups, the API that the programmer sees, and these sit on top of Rave, which in turn talks to acceleration hardware, or if none of it is available, it talks to the frame buffer directly. So you're always guaranteed to have the rendering happen irrespective of whether the end user has 3D hardware acceleration or not on their particular machine. Apple's own interactive renderer is an example of how this works. It's in fact a plugin itself talking to Rave and then down to the hardware acceleration or the frame buffer. Our wireframe renderer, on the other hand, does not talk to Rave directly, but instead talks to the frame buffer directly itself. Third-party plugins can be of either type. They can either talk to the acceleration hardware or talk through Rave. But theoretically, you could have a plugin that, for example, wrote PostScript out to a file. Okay, so what does a plugin renderer give you? On this slide you see on your left is a fine wireframe rendering in all its obfuscating glory. And on the right you see a fine ray traced image of the same model provided by Lightworks ray trace renderer, and you can see the nice specular highlights, the anti-aliasing, and that sort of pink textured area there. And I think we have a little demo on this.
Sure, yeah.
Nick?
On this machine, I've got a demo that hopefully is a realistic demo of how people are going to use this. Everybody's favorite app, well, definitely mine, Photoshop's up here. And here's some artwork that's actually been created in layers. It's just a screen of some stuff that we were getting together for QuickDraw 3D. And the kettle's kind of in the middle, but it's all a bit grayed out. And we might decide that we want something that's a bit more dynamic. So let me drop that layer out, and I can use a plugin from Vertigo called Dizzy, and plugin will load and come up. This is going to enable me to load a 3DMF object. So I'm going to load a hand in deference to Sean, our evangelist. And you can position this. You'll notice the default lighting is with the ambient light at 100%, and that's probably not what you want. So I can drop the ambient lighting down and actually bring in some lights myself. Probably want to light it from underneath for a dramatic effect. I can double-click on these lights and change the intensity, change the color. So I'm going to drop them down a little bit here, and maybe make this guy over here blue or whatever. So let's do that. Light shade of blue there. And they've also implemented some of our user interface widgets. We talked about that last year for manipulating the object, so I can basically change the orientation of it. And they've also done a lot with plugin renderers. So we have some preview renderers here. I'm going to bring up the Lifestyles demo. And this is basically a kind of artistic rendering type thing. You can do some really leery effects with that, actually. This neon one's one of my favorites because I have absolutely no taste. And I just crashed it. Okay, so basically they have the renderers within their app, and you can do a final quality renderer into the Photoshop window, which if I hadn't pressed it, I'd show you. So that's the demo.
Thank you, Nick. I'd just like to briefly mention the meta handler. If you want more details on how this works, again, the documentation, the SDK, and we have another session coming up tomorrow where we'll be going into a little more detail on this. Each class has methods associated with it. The plugins are required to implement certain methods. Other methods are optional. So essentially, all the meta handler does is provide a place for QuickDraw 3D to call to ask the plugin for the methods that implement the function that implement a particular method, and then these functions are called when that method is needed internally. I'd just like to mention elements and attributes. This is a feature that we had in QuickDraw 3D 1.0.6, I believe. There's a fine article in Develop Issue 26, again on the web. Just briefly, why do we lump these two together? Well, they're very similar. In fact, the difference is that attributes exhibit inheritance, whereas elements do not. And if that doesn't mean anything to you, I can point you to the article. There is a sample plugin attribute on the SDK to provide a sort of boilerplate implementation to show you how it works. We encourage developers who have custom information to migrate these attributes into plugins so they can be shared with other developers. And if you're looking at either the published book that we have or the develop articles, you should note that we've had a slight namespace change to make things a little more clear what functions are intended for plugins and which are not. Plugin-related API calls now have an X in them, as well as data structures. You see a few examples on the bottom of the screen. There are more. Just be aware that when you're looking at the articles, keep this in mind. In 1.5, we have introduced a new set of geometric primitives to our already rich set of primitives. In the area of labeling, we have added a pixmap marker, which is similar to our existing bitmap marker. However, it allows you to have full-color pixmaps as markers. We've added two new surface modeling primitives. In addition to our trigrid and mesh, which were previously released, we've added the trimesh and the polyhedron. I'll be going over those a little bit more. For freeform curves and surfaces, we have our existing NURB curve and NURB patch. And we've added an entire new category of primitives that we call conics and quadrics. And I guess that a torus is a quartic, so don't flame me on my math here. And these are the ellipse, the disc, torus, cylinder, cone, and ellipsoid. So with this rich set of primitives, you might be asking yourself, well, which one do I use? What's the choice? Well, we've sort of given you a little chart here that maps out how we view the complexity versus the flexibility of a primitive. At the lowest end of sort of flexibility are things like triangles and lines, but they're very simple. Going up the chain, we have like the polygon, general polygon, and up in the terms of the more flexible with some expensive complexity are the trimesh and the polyhedron. And finally, we have the NURB, the curve in the surface, and the mesh, which are by far the most flexible, but also require some work on the part of the programmer. Just have a quick view of some simple versions of our new primitives. I'd like to go into a tiny bit of detail on the conics and quadrics because we have a unique and powerful representation. If you're familiar with our previous box primitive, you know that it was defined by an origin, which is basically like a lower left corner, and three axes, three vectors that define the axes of that primitive. We've designed the conics and quadrics around that same idea. Each has an origin, which is the center, if you will, of each object, and then three vectors, orientation, minor radius, and major radius. These names are somewhat arbitrary. In addition, the torus has a ratio field in the data structure that allows you to control the width of the torus tube, if you will. Now, there's a few important things to know about this. Is that the previous slide we showed them defined with equal length, orthogonal, that is mutually perpendicular axes. This is not required, by the way, though. Non-orthogonal axes are permitted. This results in skewed objects. I'll show you an image of that in just a moment. The relative lengths of the vectors can be basically anything you want. These result in elliptical cross-sections, and of course the combination of both those two features is allowed as well. You can have skewed elliptical cross-section objects. The conics and quadrics come with a parameterization attached to them. This gives you texturing essentially for free. And this is the slide that you see is a view on the previous two slides back in the same positions with the same texture applied to each, and you can see how the texture wraps around each object. The positioning was chosen somewhat arbitrarily with the hope that the choices that we made are what most people would expect. And I think if you look at the slide, that's kind of what you would think if you put a texture around a sphere, for example. This slide shows an example on your left of a cylinder that's made with orthogonal but unequal length axes, giving you an elliptical cross-section right cylinder. On the right side, you see non-orthogonal axes with different lengths, which gives you an elliptical cross-section skewed cylinder. And these can be applied to all of the conics and quadrics. I'd like to briefly make a note of some future features for our system. If you look in the data structures for these objects, you'll see that we specify parameter limits. This allows you in both the U and V directions to make partial objects, such as hemispheres, truncated cones, and the like. This feature is not yet released, so you should note that in your code you need to set the mins and maxes to 0 and 1 respectively. If you don't, we'll catch you in the validation on the debugging library, so that's a good motivation to use that. Here's an example of how this can be used. You can see a cylinder that has a U min probably about 0.25 and a U max maybe 0.75, giving you a pie slice out of the cylinder. On the right, you see a truncated cone, which is accomplished by giving a V min of 0 and a V max of maybe 0.8 or so. Another feature that you have to be careful of is we have this idea of what's called an end cap. If you have a cylinder, for example, you can have it represent a hollow tube, or it could represent more like a child's block, a solid object. These end cap fields in the data structures allow you to place an end cap on these objects to differentiate, control whether the thing looks like it's solid or whether it's simply a tube in that case. Here's an image of what we saw just previously, this same cylinder that's made with a partial. On the left, you see the end caps are turned on, giving you the appearance of a solid object. On the right, you have the end caps off, giving you the appearance of a hollow cylinder that has a slice cut out of it. In the current implementation, since we don't have partials, we don't allow you to put the interior caps on. The interior caps are not the interior surface, so it's a bit of a misnomer, but it gives you what you saw in that previous slide, the walls on the interior cutout part. So currently you need to only use the values that you see on the slide, and if it went by too fast, the slides are on the developed CD, the content CD. I'd like to go on to the trimesh and the polyhedron, our two new polyhedral multifaceted object primitives. These are intended to supplement the mesh, which was introduced in version 1.0. The mesh is now basically repositioned on its strength, which is for freeform geometry and highly interactive topological editing. These new geometries are intended for general purpose polyhedral objects and do a bit of a better job at it if that's the intention. Both are based on connected triangular faces, vertices, and edges, so it allows for faster rendering and a more compact representation. Both the trimesh and the polyhedron, in contrast to the mesh, provide both an immediate mode and a retained mode, as the other primitives do. For both of these geometries, if you have a higher level primitive, like say a Kuhn's patch or something like that, you need to break down these faces into the triangular faces for the polyhedron and the trimesh in your application. Okay, so what's the difference between these two primitives? The polyhedron makes use of the same attribute set concept as the rest of the primitives in QuickDraw 3D, whereas the trimesh has a unique flat attribute model. So which do I use? We have 4 of these semi-competing similar data structures, these objects. Without going through this chart in a lot of detail, you should understand that the differences between these different objects, you should look at the requirements of your program, your application, what the model is intended to be used for, how it's intended to be used, and look at these characteristics and make your own determination on which would be the best primitive for your use. And again, this chart is on the slides in the on the conference CD, so don't worry that you can't memorize it at this point. Another new feature that we've added is what we call UV picking. We already have a very rich picking API. It allows you to get back the point on the object that you've picked in world space and that kind of thing. With primitives that have parametric values, that is texture coordinates attached to them, for example, the conics and the quadrics, polyhedral objects, triangular objects that you have attached these parametric values to the vertices, gives you the ability to return the texture parameter at the point of picking. This allows you to do things like painting on objects. There's a sample app on the SDK called Box Paint, and I think that Nick is going to show you an example of how this works.
So I'll try and do another demo that doesn't crash on this machine. So this is an app written by Michael Bishop in the QuickDraw 3D group called Box Paint, and it uses UV picking, so I can kind of reorientate the subject. It's just intended as a kind of sample code demo of how you can use this stuff. But he's implemented a couple of neat things. For example, the pencil is drawn transparent, and you can kind of draw silly pictures. So I'll draw a kind of cartoon dummy picture. We're going to talk a little bit about the picking tomorrow in the more technically oriented session. We'll talk a little bit about how you could implement this. And basically, because of the way the box is parameterized, the text is shared on all four faces, so you see it on all four faces. I'm going to dice with death as well and go back to the Photoshop thing. You can see here the hand's been drawn with the interactive renderer, and I don't know if you can see it there, but I can certainly see it here, that there's quite a lot of aliasing around the border of the hand. We've got a renderer from Lightweight Design, which is a very high-quality renderer, which supports shadows, anti-aliasing, and transparency, and I can actually use that to render this image back into my main Photoshop window. So you see the progress bar at the bottom of the Dizzy dialog, and it appears in our Photoshop window. So that's plugin renderers in action.
Another new and quite useful feature that we have in 1.5 is what we call a file reference. Previously, without this feature, you were often required to have very large files, and there was no way to modularize them, at least without doing a lot of work on your own. What this allows you to do is to reference one file from another and create essentially hierarchies or libraries of 3DMF files, which allows the files to be smaller, allows you to organize your own database more rationally. It can also reduce the bandwidth and download time, because you can reduce the size of each individual file. Structurally, this is what it simply looks like. One meta file that's on the left contains a reference to a second meta file. So while the first file is being read in, it hits this reference, goes off, reads the other file, makes the data structures or the objects, and then returns to reading the first file. And this can be done I can say recursively, but it can be done hierarchically. In other words, more than one level of metafile references allowed. So metafile B could itself have references, and so on. This level of detail is not a new feature in 1.5 per se. Rather, we're presenting this as a sample on our SDK and the conference CD to show people how to use plugin groups. Briefly, what it does is allows you to have the same object represented by several proxies that are at different levels of resolution, and which model is shown depends upon the extent of the rendered image on the screen. So as you get further and further away, you can substitute a simpler, coarser model to increase your rendering speed. And again, the source code for this is on the conference CD. So
I actually have a demo for that guy over here on Windows. basically, this is the viewer. In fact, pretty much all of this demo was written by the guy who wrote the viewer, Ichiro Mikami, in the Quiddraw 3D group. It's a pretty cool demo. It doesn't look like much, but I'll explain what's going on here. We're actually using two plugins here. The first one is a plugin level of detail group. And you'll see that as I move the object away from the camera, we change the geometry. It's kind of difficult to see what's going on there. So another thing we have here is a plugin wireframe renderer for Windows. It's a pretty simple renderer. It doesn't draw amazingly fast, but if you're planning on implementing a plugin renderer, this would be a good place to start, along with the other sample plugin renderer. And you'll see how the geometry actually changes as we change the distance from the camera. So it's not the whizziest demo in the world, but it's pretty cool. And we're giving you all of this code on the SDK. Mac versions of this are on the technology CD that you have, and we'll have the Windows versions on the final CD and also on the web as soon as we can get them finished.
Another new feature that's I/O, I guess this should have been a couple slides back for organizational purposes, but it's what we call group traversal control, or more informally, diving into groups. Previously, if you encountered a group object in the meta file, we read it in as an entire group. And some developers have asked us to allow them to sort of dive into the group and start reading again object per object in that. So instead of being given one monolithic group, programmatically, you can step into that group and read the contents of that, and with groups, thin groups, and so on. And my apologies for having code up here instead of a block diagram or something easier to read, but you can see the bottom two function calls allow you to set the state, that is, tell it to dive into groups or not, and allows you to retrieve the current state of that state variable, if you will, to tell you whether you're reading entire groups or where you're reading the objects per object in the group, and also tells you whether you're currently inside of a group. Another feature that we've added is what we call adaptive tessellation. This is controlled by the subdivision style object, for those of you who are familiar with our API. This is another level of detail mechanism that allows you to change the subdivision on smoothly curved curves and surfaces, such as NURBS or the conics and quadrics, that gives you control over how many triangles we turn this into. In screen space, the units are pixels. So, for example, you can specify a value of 20, and the triangles that are seen on the screen will have legs of length 20 or less, irrespective of the size of the rendered object on the screen. So as you get further away, you get fewer triangles, but they're the same size, so you get the same apparent smoothness. And as you get closer, you get many more triangles. And I believe we might have a demo on this now.
Yeah, on this machine. What we've actually got is a NURB patch, and you can see that it's not very finely tessellated right now. And I brought up the tessellation dialog from a test app we use called Spin. You can see that we're tessellating the screen space at a value of 32. If I reduce that, you'll see that, oh, sorry, learn to use this. If I reduce that to 12 and apply it, you'll see that the object becomes more finely tessellated. The interesting thing is, as I move the camera towards the object, you'll see that the tessellation, in other words, the number of triangles that this patch is divided into, increases, and as I move it away, it decreases. So this can be a really effective method with the conics and quadrics and the NURBS of kind of doing level of detail and reducing the complexity of stuff that needs to be rendered as it falls off into the distance.
Another piece of functionality that we are soon to release, it should be, as we say, real soon now, is the Netscape plugin. Now it supports Quickdraw 3D 1.5 and 1.5.1. Briefly, what the Netscape plugin allows you to do is embed 3DMF in your HTML documents and then view these, which happens to use the viewer, by the way, through Netscape Navigator or Internet Explorer, heaven forbid. And this will be out sometime within the next month or so, I believe. And do we have a demo on this, Nick?
Yeah. So here we have Mikey's Jet page. I guess we have a young adolescent who wants to be a jet pilot when he grows up. Basically, we've got a couple of 3DMF objects embedded in here. The first is the spinning QuickDraw 3D logo at the bottom, and the other one is this guy, and I can change the orientation. It's basically live 3D data, and it uses the viewer, and I can kind of mess around with this. The advantage of doing it this way is, I'm sure you've seen on our homepage, we actually have a spinning QuickDraw 3D logo, and it gets downloaded as a bunch of GIFs. Well, it turns out that the size of this model is actually about the size of 1.5 of those GIFs, and I think in order to do the full rotation, there's 12 GIF files. So certainly if you're doing web pages and you want to get snazzy effects on them, putting 3D data on them makes a great deal of sense because you're going to reduce the bandwidth of stuff that your users are going to need to download. Other things that we're investigating at the moment, but we want to hear from you about whether you want that, is ActiveX controls. So that's one direction that we could head in, and we're certainly going to do a Windows version of the Netscape plugin, which will also work in Internet Explorer.
Thank you, Nick. As David mentioned earlier, we've made some improvements to the viewer, and just to go over them again, we've improved the virtual sphere interaction, provided camera pop-ups that change your view or get you back if you've managed to scroll your object off the screen. Improved support for drag and drop, and as far as the API goes, now we have separate calls for the control strip and the content window for those of you who are using the viewer within an application. There's a develop issue, number 29, can give you more information on the viewer, its capabilities, and how to use it. I encourage you to take full advantage of that. I'd like to step now into a topic that's not a new feature, but we consider significant enough to mention for those of you who are not familiar with it. It's QuickDraw 3D Rave. Rave is our low-level hardware abstraction layer. It's basically targeted at games, simulations, and other high-performance demand applications. Rave is our hardware abstraction layer. This allows us to talk to one API from the standpoint of our renderers rather than having to put device-specific code within in a renderer, either ours or a plug-in renderer. And it allows the hardware vendors to support one API from the underside, if you will, rather than having to be talked to by different renderers. So it's a benefit for both the renderer itself and for the hardware developers. It's a very thin layer. This allows us to get as maximize the access to the hardware's capability. What Rave does is it accelerates rasterization. In other words, it's a 2.5D mechanism. You get rasterization plus depth that allows you to do hidden line, hidden surface removal. The API has been built around the idea of providing the features that can run most efficiently in hardware. There's a few concepts in Rave that you need to understand sort of from the top level. The first is what we call the Rave Manager. This is part of the QuickDraw 3D Rave shared library. The Rave Manager is responsible for handling the different Rave engines, which are the individual interfaces to different hardware devices, or failing that, the software rasterizer. It also provides the application with information as to which Rave engines are available for use in that application. The second idea is what we call a drawing engine or a Rave engine. This is a shared library that the Rave Manager calls, which implements the interface to the particular piece of hardware. Rave also has a concept of a draw context, which is very similar to the QuickDraw 3D draw context, but it's somewhat lower level in accord with the lower level nature of Rave itself. A draw context is simply a rectangular region into which you draw. Associated with the draw context is a clipping region. This provides the information as to what parts of the draw context to not draw to. So for example, if you have occluding windows and you're running single buffered, then you don't get the occluding window getting drawn over. And this is handled by the Rave Manager for the benefit of the Rave engine. What does Rave do? Rave provides currently a Garot shading model, perspective correct texture mapping, support for Z-buffering or for not Z-buffering if that's what you want. The tri-mesh is implemented there fairly directly, giving the tri-mesh a good edge on speed. And it provides a number of texture formats, including what we call CL8 and CL4, which are basically indexed 8-bit and 4-bit texture maps. This gives you an idea of what the Rave architecture is in a larger sense. If you look on the right, ignoring the game box there for a moment, an application typically would talk to QuickDraw 3D's API, which handles cameras, lights, transforms, that kind of thing. The interactive renderer then takes this information and culls and clips and computes the vertex shading on the triangles or whatever primitive you have. These are then transformed into raster space and then handed off, the triangles that is, or lines, to the Rave manager as 2.5D primitives. In other words, this sort of screen space with depth information. The Rave manager then selects either the Rave software engine or a Rave compliant driver, which is a Rave hardware engine, which then can talk to either software in the first case or hardware in the second case. Typically what we've seen so far and what we are encouraging is that applications such as games, which have very particular rendering or performance needs, they can talk to the Rave manager directly, which then again talks to the Rave engine as appropriate. The advantage of this is that it allows the game to write directly to Rave without having to go through QuickDraw 3D's API if they so choose. There's a few things that we currently do not support. As I mentioned, this is a 2.5D level, if you will. We don't support geometry processing or lighting model or clipping. That is handled by the renderer that is feeding the Rave manager. In addition, multiple monitors require intervention on the part of the Rave user, be that a plug-in renderer or, as seen in the previous slide, a game. In the case of a multiple monitor, you need to have separate draw context for each window, for each monitor. The future of Rave. Well, we have a number of features that we're considering introducing to Rave. You see a partial list here. We encourage those of you who are Rave users or, in the case of hardware people, Rave providers, if you will, to come and discuss with us what kind of features you would like to see as either a user or a developer of that. Any changes that we make will, of course, be backwards compatible, so you needn't be concerned about existing code breaking.
So I've actually got a demo of some Rave stuff here, which certainly isn't as impressive as the ATI demo, but we had a number of developers ask us for some Rave sample code. So Steve Luce in our group actually wrote a pretty cool Rave sample, which you see up here. On the left-hand side, as you see it, it's drawing using Apple's kind of aging hardware card compared to some of the other stuff we've seen today. And on the right-hand side, we've got it using the Apple software renderer, software rasterizer rather. Basically, what we're doing is supplying this as sample code. If any of you use it or have comments on it, please get back to us because we'd really like to enhance this. And if you have any other requirements for Rave sample code, particularly let us know. And Phil's going to come to this later, but tomorrow we have a feedback forum, and we'd be particularly interested in receiving feedback on what kind of directions you'd like to see in terms of where we're going with hardware.
And by way of heading towards a wrap-up here, I'd like to just go over a few of the new API calls for 1.5.1. These are mostly in the area of more support for plug-in renderers. We've added features to allow the application to determine whether a plug-in renderer is intended to be for interactive use or not. We allow the application to set and retrieve custom configuration information for a plug-in renderer, and also for a renderer to get the preferred name of a plugin. This is mostly for UI purposes. I won't go into any more detail on that. You can attend the session 307. Nick will go into considerably more detail on how these are used and what their benefits are. In addition to some of these new API calls, we of course have the number of bug fixes in response to a developer request to fix some outstanding bugs, panes and masks on Mac and draw context. The Pixmap Draw context now allows for alphas, which is very useful. We've provided more support for the idle methods and some various and sundry other bugs that have somehow slipped through in 1.5. For more information, you can again, please do make use of the Develop magazine articles that are available on this website. We invite you to participate in our mailing list, and you can simply send a help as the title of your email to the address you see there. There's quite a bit of activity on there. You can get information from us, ask questions of other developers, and just basically listen in on what's happening. The QuickDraw 3D website at the address you see here also contains a lot of useful information and pointers. Here's a few of the awards we've won, though maybe not all. A gratuitous pat on the back for our team. And by way of wrapping this thing up, we invite you to attend. We have 2 more sessions that are related to QuickDraw 3D. Tomorrow we have session 307, which was called QuickDraw 3D Tips and Tricks. That's at 1:50 tomorrow. And we have a feedback forum, which you very much encourage interested developers to come to tomorrow late in the evening, where you can come and ask questions, have your needs addressed, suggest things on any topic that you'd like. I think that brings us to the end.
So it turns out we weren't quite expecting this, but we've got some time left over for some questions. So if you'd like to come up to the mics, they're in the aisles. And if I can invite the other members of the QuickDraw 3D team who are in the front and 3dFX guys up, we'd be happy to take your questions.
Go ahead.
Question: is QuickDraw 3D multi-threaded?
Currently, QuickDraw 3D is not multi-threaded.
Will it be?
Yes, it's our intention to make it so for both Windows and Rhapsody, and obviously for the Mac. I can't say which time frame that'll be in. We'd like to get it into the next release, but I'm not promising anything.
Thank you.
But we would anticipate it being so, within the next year.
Are you looking at OpenGL support in any sort of way? The integration with Direct3D that you mentioned, for instance, seems interesting. Yeah, currently we're doing a lot of work investigating exactly what card vendors need in a hardware acceleration layer. So we have a variety of options, and we're actually, it's funny you should ask that question because we're currently evaluating a whole bunch of options. I don't really want to go into too much detail about what they are, except that the most likely direction we're going to be going in is to provide the things within our hardware acceleration layer that will allow you to host OpenGL on top of that. It's kind of likely that if you're familiar with Microsoft's MCD stuff, MCD, the mini client driver on Windows, supports only rasterization, which is where Ray's at right now. One possible direction for us is that we could extend that to include things like geometry and lighting calculations that cards will be coming out with in the future. We expect to be much firmer on where we're going with this in a few months' time. But right now we're talking to hardware developers and talking to software developers basically to see what they want and to see what we can actually do.
We'd also appreciate your feedback, that if you have any recommendations or options or reasons, for one platform or another, we'd encourage your feedback. Please come up and let us know, either here or at the feedback session on Friday.
And yeah, I would definitely reiterate what Dave just said. If you do have specific requirements, particularly if you're developing hardware, we'd really like to see the feedback forum. And if you don't want to ask your questions in public, that's cool. Just send us an email.
Okay. You talked quite heavily about the 3D plugin and your 3D viewer and programming directly in QuickDraw 3D. But everywhere else in the conference, we keep talking about that QuickDraw 3D is a subset of the QuickTime multimedia layer. They keep telling us the thing to do is to use the QuickTime plugins, because then you can do it on the fly. There's a session about that later today. What's your suggestions? What's the advantage of using 3D Direct? And
we would definitely encourage you to use the QuickTime stuff. I mean, we see ourselves as one small component in the QTI layer. you know, for example, if you wanted to provide animation, you could do that today by using QuickDraw 3D for your geometries and using the QTI interpolators to actually interpolate your matrices. So, you know, we definitely see ourselves as being like at the bottom of that. So I'm sorry if we didn't address that, and that's certainly an omission, but we are working very hard to get ourselves very deeply integrated in QTI. And,
for example, the plugin, which do you recommend, using the 3D plugin or the
Well, I mean, the plugin
QuickTime
thing's interesting because for rendering, that's not really an applicable QTI plugin. Because the rendering subsystem's called by us, but then you could have a plugin for the QTI stuff that calls us, and we call the plugin to do the rendering. So our plugins are not really the same kind of thing.
You misunderstood. I meant the Netscape plugin.
Sorry?
I meant the Netscape plugin.
Oh, the Netscape plugin. Yeah, I mean, the Netscape plugin is something that we just did because people were asking for it. And it's something that we did a while back, and it didn't work with 1.5, so we wanted to upgrade it to work with 1.5. But yeah, I mean, definitely for the web stuff, right now the quick hack way is to use the plugin. In the future, I'm sure that you're going to see a much more integrated offering so that you would use QuickTime's method for doing that.
Can you use the, can you call the QuickDraw 3D API from MPTask from Apple's multiprocessing?
Yeah, that goes back to a question earlier from a guy at that microphone. No, it's that microphone. Which microphone was it? Basically, because we're not re-entrant right now, it would not be safe to call QuickDraw 3D from multiple threads. But what you could do is have one thread which does QuickDraw 3D stuff. The problem that you're going to have is that we rely on underlying system services for some things, like copying bits around, that may not be re-entrant. So, you know, right now you can try it and it's going to work in some cases, not in others. In the future, we want to have a fully re-entrant library. Go at this mic.
I love being short.
We charge a lot for appearance fees.
I've got a number of questions, so I hope you'll be just a little bit patient with me.
Okay.
The first, I saw that fighting demo. I was just wondering what type of machine that was running on.
8500 with the 3DFX development card inside. So 8500.
Is that demo made available to us?
Yeah. If you get on the developer relations with 3DFX, website, you can get a board and software.
Oh, okay. Thanks for that. And you mentioned, you mentioned about the macOS, or in the blue box you showed System 7.x, and that kind of made me wonder because I'm testing macOS 8 right now. I was just wondering, under the blue box, this is going to work under macOS 8, right?
Yeah, it does work under Tempo. We've actually got it running in our lab.
Depends on where you are in the development cycle. In the early versions of Blue Box, it was based on 7.6. The latest versions of Blue Box that are being under tested now is macOS 8. When you get your first development release, it will also be based on macOS 8. So 7.6, 7X, and 8.0 compliant.
So is the structure that different that there needs to be changes to make QuickDraw 3D render under macOS 8?
No, there are no changes to QuickDraw 3D.
Okay, well, that's a plus. Now, QuickDraw 3D walkthroughs, you were talking about how you could have these walkthroughs. Can you integrate those in the QuickTime VR worlds and scenes? Kind of like they were showing a demo in the QuickTime 3.0 demo, a QuickTime VR scene, and they had QuickTime running on a TV inside of it. So could I have a QuickTime VR world and also have a QuickTime 3D walkthrough within it?
You may want to talk to the QuickTime VR people, but I believe the QuickTime VR 2.0 development kit actually allows you to call either QuickTime Movies or QuickDraw 3D objects. So that would be better to follow up with the QuickDraw VR team.
I'm just wondering if you could have a QuickTime 3D object within a QuickTime VR object.
Yes.
Yes, you can. The thing that you can't do today that we've kind of been talking about, but it's kind of hard to do, is actually having VR within a QuickDraw 3D scene. So you can definitely have 3D in a VR scene, and that's relatively straightforward, but going the other way is not so straightforward.
Okay. One other thing.
Okay, I'm going to have to limit you to one more question because we've got another
That's
people
fine.
and we're running out of time.
I appreciate your time. When loading the reference files, you were mentioning how it can have references within the QuickTime 3D or QuickDraw 3D, pardon me, files. Can you load more than one reference at the same time? Just thread that off?
Yeah, I mean, you can have a file that contains multiple references. I actually had a demo which I didn't bring, which maybe I should have brought, which has a very small meta file which calls, I think it's 5 other geometries, and you can change those geometries to use other files. So yeah, you can have multiple references in there.
Okay, great. Thank you for your time.
Great, thank
you. Okay.
Yes, with regard to your level of detail rendering feature, where the camera is farther away from the object, it'll render it in a coarser manner. Can you change the parameters on that feature, and how do you do that?
For the adaptive tessellation approach?
For the level of detail plugin or the adaptive tessellation?
Well, I had an app.
The plugin thing we were showing on Windows, right?
No, just within QuickDraw 3D.
Yeah,
I had an app that was running, and then under 151, I saw this come up. I thought it was a bug in my program, actually. But it was just that the object was farther away and was being rendered coarser.
Oh, right, yeah, that's basically adaptive tessellation. And within the viewer, there's this interesting feature that times how long it takes to render a frame, and if it took too long to render the frame, tries to re-render it with a lower tessellation. That's something that some people would argue is potentially a bug. Yeah, it's there, and we're looking at it.
Can you turn it off?
You will be able to in the future, I think. Yeah. I mean, I talked with Ichiro about this yesterday, and we didn't really come up with a conclusive fix, because one of the demos that I've got uses a hacked viewer that doesn't do that. It seems that the most sensible way to provide a solution for it would be to have a viewer flag, which turns off the adaptive tessellation or turns it on, in the same way that you can turn on and off the drag border. Thanks. Eric, good to see you.
You know, in the keynote address, they had this picture of a yellow box, and they had the things that they're putting in the yellow box, and then they had, one of them was QuickDraw 3D went in there, right? Remember that? And then they said, later on they said, well, everything in this yellow box is going to have a Java API.
Yeah. So
I said, does he just say the QuickDraw 3D is going to have a Java API? That's what he said, right?
Yeah.
So you guys are going to do that?
And the demo that they showed during the keynote was actually driving the 3D app from Java.
When did we get that?
In the Rhapsody Java session, he showed how he actually implemented that.
When do we get it? Or how do we get it?
It'll probably be in the developer release for Rhapsody, I would think. I'm not
Maybe
sure
not the developer release, but probably
inside
inside of the Premiere release.
Yeah. I mean, we'll get that.
Sorry, there's actually a session going on tomorrow where he's actually going to pick apart that demo and build it from scratch and give you all the details on how that's implemented. Most of the QTML stuff is going to be implemented inside of the Premiere release and then rolled together inside of Unified.
Cool. Yeah, I mean, it's an interesting question because one of the things that, again, we've been discussing amongst ourselves.
Is threads.
Not so much the thread stuff, but actually rewriting the viewer in Java so that we don't have to do different implementations on it for every platform.
But you didn't mean just the viewer, you meant the whole...
No, he meant the whole thing.
So if I want to get a camera, I can get it and change it around from Java. Or if I want to get a... Okay.
And my understanding is that Java bindings will be provided for that.
Very good. I have 50 more questions, but I'm going to go to the end of the line before I get to
we're kind of running out of time here, so if you don't get your turn on the mic, please come find one of us afterwards, and we'll be happy to answer your questions.
Yeah, you mentioned...
we have 1 minute left, so I think you're the last question.
You mentioned VRML browsers that were available and stuff. I didn't quite understand how much integration you were talking about with regards to VRML. I had understood that Moving Worlds was supposed to be using the 3DMF file format or something along those lines. How does it all fit together? Are we seeing a lot more integration or what?
We're actually working with IBM and Paragraph to define that next generation binary format. So we're actually working, so each part of the three companies are actually contributing different standards. So I believe IBM's contributing compression standards, Apple's contributing parts of our binary 3DMF file format to create the next generation standard. So it's still in process of getting everything put together, but that's sort of how we're working together.
Is that Vermal? That's not Vermal 2, because that's pretty much been decided upon. I assume this is a subsequent version, yes?
Yeah. We'd be real happy to talk to you about this offline, but we just got the bomb box from Bruce.
Okay.
So if we don't go, they'll turn the power off. So thanks a lot for coming, and please ask us any questions if you have them.